Well, then it won't matter if your friends are.
Okay, so number 23, if we're solving for x, okay, solving for x on number 23. First thing you have to do is square both sides. Okay, square both sides. If you square both sides, that gives you 3x plus 12 equals 3 squared is 9. Root x squared is just x. Okay, if you have numbers and letters here, if you do not have anything with a square in it, you want to get numbers and letters on opposite sides of the equation. So move this over. So if we subtract 3x, that gives us an equation of 12 equals 6x. Divide by 6 to get x by itself. You get an answer of 2 equals x. Yeah, that's it. Yes. Okay, for number 24, again, solve for x. To get rid of this root, we're going to have to square both sides. Okay, square both sides. So this radical cancels out the root, leaves you with 44 minus 2x. Equals, remember, if you have a binomial, two things in parentheses attached by a plus or minus, you have to write it out twice. Okay, you can't just distribute that square. So we got 44 minus 2x equals, FOIL these together, that's x squared minus 10x plus 100. Okay, whenever you have something with an x squared, we always want to move everything to one side and get it equal to 0. For this one, do I want to move everything to the left side or the right side? The right side, because I want the x squared terms to be positive. So subtract 44 and add 2x. Subtract 44, add 2x. I'm going to line them up so that they'll be in line. Okay, these go away, so we get 0 equals x squared, negative 10, another negative 10 gives you negative 20, plus 2 is negative 18x. And then 100 minus 44 gives you plus 56. Okay, this will factor. Okay, what's going to factor to give you, what multiplies to 56 adds to 18? 7 and 8 add together to give us 18?
No.
Yeah, I don't think so.
4 and 14.
4 and 14?
Yeah. That's not right. Yeah, it is 4 and 14.
4 and 14 work. Okay, so minus 4, minus 14. I was waiting for you guys to decide. Okay, then break these apart. You get a positive 4 and positive 14. Now, you have to check this. Okay, you cannot assume that both of them are answers. On that last quiz, a lot of you guys did not check things. Okay, and that was where you made mistakes. So, first we're going to check 4. So if you do root 44 minus 2 times 4, is that equal to 4 minus 10? Okay, so we got root 44 minus 8, which is root 36. Does that equal 4 minus 10 is negative 6? Is root 36 equal to negative 6? No. 4 does not work. Now, do not assume that 14 will. Okay, we have to check both of them.
Will there ever be like when none of them work?
It is theoretically possible for none of them to work, but it's not going to happen on your test. Okay? On your test, at least one will always work. Sometimes both works though. Okay? So plug this in. Root 44 minus 2 times 14 equals 14 minus 4. Okay, so root 44 minus 2 times 14 is 28. Equals 4 minus 14 is? Did I do that right? Sorry, minus 10. I was doing the, never mind. Equals 4, sorry. Okay, so root 16 equals 4. Is the square root of 16 equal to 4? Yes, so your only answer is 14. Okay, only answer is going to be 14. Okay, on 25, it says identify the domain of the relation whose graph is shown. Identify the range of the relation whose graph is shown. Is the relation a function? All this stuff, okay? Whenever you're identifying domain, domain is what? The x's or the y's? The x's, right? So here, you just need to label these points, okay? If If I label this point, this is at negative 1, 2, 3, 4, 5, 6, negative 6, negative 2. This point is negative 4, comma 1. This point is 3, 2. And this point is 4, negative 1. Domain, you just make a list. Okay, so negative 6, negative 4, 3, and 4. So make a list of the x's. Range, make a list of the y's. Negative 2, 1, 2, and negative 1. Now, if it was multiple choice, you might have to figure out which ones match. They may have written it in smallest to largest or largest to smallest. Could be left to right, right, left, doesn't matter. Okay, as long as your list is correct. So, is this a function? Yes. Okay, because no matter where you put a vertical line, it would only cross one time. Now, why is this one not a sandwich? Does anyone know? Anytime you just have points, or if you have a list, you just write them all out. This one is different because it's solid in between. So it would cover everything in between. That's when you make the sandwich. Okay, so here, the domain is the x's. So what are the x values in between? In between here and here is what? Between 0 and, is that 6? 0 and 1, 2, 3, 4, 5, 6. So x is in between 0 and 6, and it's sandwiches. Okay, sandwich in between. How about the y's? What is y sandwiched in between? The lowest y value is what? 0. Whoa, negative 1. This is at 0 right here. 0 and what?
2.
That's 2? 3. 0 and 3. Is this a function? Does it pass the vertical line test? Yes, it is a function. Okay, yes, it is a function. Did you say what's the vertical line test?
She said it's kind of cute.
It's a little bit.
How do you?
Okay, if you're having trouble with it this way, what you can do is you can label the endpoints. Okay, label like where it makes a sharp point. Okay, so this point would be 0, 2, right? This point would be 1, 0. This point is 6, 3. Domain is talking about the x's, so what's the smallest x value? 0. And what's the largest x value? 6. So that's your domain. Then look at the y's. The smallest y value is this one. The largest y value is this one. So you're not always using parts from the same points. You might be using, like, we use both parts for this one, but only one part and one part. So you just have to figure out which ones are useful to you. Okay, 27. If f of x equals 2x plus 5, g of x equals 2x plus 7 over 3, find g of f of 7. We always start from the inside and go out. So first I want to find f of 7. So plug in 7. So if f is 7, plug in 7 for x. So 2 times 7 plus 5. That gives you 14 plus 5, which is 19. Now, hopefully we can agree that instead of writing f of x, I could substitute that with 7, right? So if I just replace that with a 19, I might have misspoke, sorry, 19, now I'm going to plug into the g equation, plug in 19. So g of 19 equals 2 times 19 plus 7 over 3. What is 2 times 19? 38 plus 7 over 3. What is 38 plus 7? 45 over 3, which reduces to be 15. So whenever you're doing these are called compositions. You just want to go from the inside and move out. Okay, you're always going from the inside and moving out. And then the last one on here is number 28, to find the inverse, okay? Before you can find the inverse of something, what are the 2 things that do not have an inverse? There is no inverse. You cannot do it if you have an x squared in the equation or any constant number. Any constant means there's no x's or y's. It's just like a number. So x equals 3 or y equals 2, something like that. Okay, so if there's no other parts involved. Okay, so this one is fine. Are we good on this one? Can I find an inverse of this one? Yes. Okay, so it's already in y equals form. It probably should have started as something like f of x. Okay, so it's already done the first problem, or the first section. Now replace this. So we have y, then switch the x and the y. So x equals negative 1/5 y plus 2/5. What do we not like about this equation? The fraction. How do we get rid of that fraction? Multiply all the parts by 5. Every single part. Okay, when we multiply by 5, this just becomes 5x equals, these will cross reduce each other, so you get negative 1y plus these 5's cross reduced again. We get a 2. Okay, that's a lot nicer. I don't have any fractions anymore. Then I want to get y by itself, so move the 2. Leaves us with 5x minus 2 equals negative 1y. How do I get rid of a negative 1 there? Divide by negative 1. Remember, you have to divide all the parts. So when you divide it, it becomes negative 5x plus 2 equals y. And this should have started with an inverse. Okay, so this would be like f negative 1 of x equals negative 5x plus 2. Okay, so that's how we find inverses. Do we have any questions?